A new study in Science Advances led by UMBC's Tianle Yuan used satellite data from 2003 to 2020 to determine the effect of fuel regulations on pollution from cargo ships. The research team's data revealed significant changes in sulfur pollution after regulations went into effect in 2015 and 2020. Their extensive dataset can also contribute to answering a bigger question: how do pollutants and other particles interact with clouds to affect global temperatures overall? Tiny particles in the atmosphere, which are called aerosols and include pollution, can harm human health, but they also often have a cooling effect on the planet because of the way they interact with clouds. However, estimates of the extent of that effect range by a factor of 10, not very precise for something so important. How much cooling the aerosols cause is a big unknown right now, and that's where ship tracks come in, says Yuan, an associate research scientist at the Goddard Earth Sciences Technology and Research (GESTAR) Center. Sea of data. When pollutant particles from ships enter clouds low in the atmosphere, they decrease the size of individual cloud droplets without changing the total volume of the cloud. That creates more droplet surface area, which reflects more energy entering Earth's atmosphere back to space and cools the planet. Instruments on satellites can detect these differences in droplet size. And the air over the ocean is generally very clean, making the relatively narrow ship tracks that snake across the ocean easy to pick out. Most of the original cloud is unpolluted, and then some of it is polluted by the ship, so that creates a contrast, Yuan explains. While ship tracks can be relatively obvious in satellite data, you have to know where to look and have the time and resources to search. Before advances in computing power and machine learning, Yuan says, Ph.D. students could focus their entire thesis on identifying a group of ship tracks in satellite data. What we did is automate this process, Yuan says. His group developed an algorithm to automatically find these ship tracks from the sea of data. This huge advance allowed them to generate a comprehensive, global map of ship tracks over an extended period, 18 years, for the first time. Next, they will share it with the world, opening the door for anyone to dig into the data and make further discoveries. Only areas with certain types of low cloud cover had ship tracks, which is useful for adjusting the role of clouds in climate models. They also found that after Europe, the US, and Canada instated emission control areas, ECAs, along their coastlines in 2015, ship tracks nearly disappeared in those regions, demonstrating the efficacy of such regulations for reducing pollution in port cities. Ports in northern Mexico, not part of the ECA system, saw increased activity and pollution hotspots built up along the boundaries of the ECAs as ships altered their routes to spend as few miles as possible inside the restrictive zones. After that, the only ship tracks the team's algorithm could detect were those in the cleanest clouds. In clouds with even mild background pollution, the presumed ship tracks blended right in. However, because particles, such as shipping pollution, have a cooling effect when interacting with clouds, reducing them significantly could contribute to a problematic uptick in global temperatures, Yuan says. That's another reason it's important to firm up the degree to which particulate pollution cools the planet. If the cooling effect of these pollutants and other particles is significant, Humans will need to balance the need to prevent extensive warming with the need to reduce pollution where people and other species live, which creates difficult choices. Ship pollution alone can create a substantial cooling effect, Yuan says, because the atmosphere over the ocean is so clean. There is a physical limit to how small cloud droplets can get, so at a certain point, adding more pollution doesn't increase the cloud's cooling effect. But over the ocean, because the background is largely unpolluted, even a small amount of pollution from ships has an effect. Ocean pollution is also an outsized driver of the cooling effect of aerosols, because low clouds, which are most conducive to creating ship tracks, are more common over water than on land. We can take advantage of the millions of ship track samples we have now to start to get hold of the overall aerosol cloud interaction problem, Yuan says, because ship tracks can be used as mini-labs. By analyzing data from a relatively simple and well-controlled system, narrow ship tracks run. That spirit of collaboration will help scientists and communities determine how best to approach global challenges like pollution and temperature change. Science Advances, 2022. 8-29, doi. 10. 1126, SCIADV. ABN 7988 University of Maryland Baltimore County. First global map of cargo ship pollution reveals effects of fuel regulations. Ship tracks in clouds also help explain how particulate matter interacts with clouds and affects global temperatures. Science Daily. Science Daily, 2 August 2022. ift.tt/xgkwjn6. University of Maryland Baltimore County. 2022, August 2. First global map of cargo ship pollution reveals effects of fuel regulations. Ship tracks in clouds also help explain how particulate matter interacts with clouds and affects global temperatures. First global map of cargo ship pollution reveals effects of fuel regulations. Ship tracks in clouds also help explain how particulate matter interacts with clouds and affects global temperatures. Science Daily. https://ift.tt/xgkwjn6. Accessed August 2, 2022. Thanks for watching. Please subscribe my channel for more videos.